Hello everyone. We'll be starting with a new lecture series now on electromagnetic compatibility in railways. You have previously seen few lectures on traction power, earthing, bonding, stray current and lightning protection. If you want to go to view them again, you can go to my link, or if you are new to the channel, I will provide you the link in the description box. Like in those videos, we always started the topic with very basic understanding so that any field, like it's not only electrical electronics but any civil, mechanical, or maybe even the management people can understand what basically is EMC. So we will be covering few videos only talking about basic understanding, and this is one of that video. Then we'll be talking about other measures such as cable segregation rules provided in various standards, best practices that have to be followed, and we'll also understand how to read the standard and what are they talking about, and how actually you can implement those measures which are given in these standards such as 61000-5-2 or 6364 or 6364-4-44 and many others, 5174-2-3. All these standards we'll be discussing separately, that what are the methods, what are the mitigation measures that have been given, the practices that have been given, and how you have to implement in your case. Then we'll be talking about induced voltage analysis, which is one of the important topic, in which we'll see how manually we can solve, not only using software but how manually using the standards such as ITUT volume 2, 3 and 4, how we can go ahead and solve everything manually related to induced voltage analysis. And then later on, which is a very good topic to understand the things, is that you are not compliant to everything. Even if you say that I am compliant to this or that, there will be some cases where you are not able to achieve what was required, so that becomes your risk. So we will identify the risk, what are the common types of risk that we see. Not all can be done, we will take some examples of the past experience and we'll add those, how to form this risk analysis. Then we'll be talking about the test, what are the tests required to be done for EMC as per the required standards, and also at the end we'll be talking about all the mitigation measures that have to be taken in order to mitigate the risk. Now let us start with this chapter or this lecture, which talks about basic understanding what is EMC. Now, as per the definition provided by the book, that is the standard, which is IEC 60050-161, it tells us that EMC is the ability of an equipment or a system. Very important to note, it is not only equipment but it is also telling that equipment or the system, sorry for choosing the wrong color, of the equipment as well as the system or the system. So basically not only your equipment shall be compliant but your whole railway system shall be compliant, or whole subsystem which you are making, whether it's power or signaling or telecom or MEP, all shall be compliant. Then only you will achieve EMC, not only by providing equipments which are compliant. So going back to the definition. So EMC is the ability of an equipment or system to function satisfactorily in the electromagnetic environment without introducing intolerable electromagnetic disturbance to anything in that environment. Now this definition is a bit heavy and we said that we will not go into deep technical. So let us take an example so that everyone can relate to what is EMC. And this example is of coronavirus. Yes, everybody knows now, in 2019 it started, COVID-19, and now everybody is aware of what was it and what mitigation measures had to be taken, or what we followed the steps in order to avoid getting it. So the first step was that there is a sick person and there is a healthy person. Initially when we came, this virus was newly introduced in our lives, I would say. So first thing was told to us is to follow social distancing. So by creating distance between the two people, at least 2 meters, that was written everywhere, that if you follow a social distance, then you will be able to not get the virus, you will protect yourself most probably, because the person can emit something that can be virus from his mouth or nose that will not reach you. This was the basic philosophy behind it. So anything which is emitted through air, it is called radiated. This is just a technical term which we will see in EMC. So next thing was told to us that you will not always be obviously maintaining social distancing 100%. There will be some cases, and somewhere through the air, somewhere nearby, corona can enter into your ports. Now ports means basically nose and mouth. So what was told to us? To wear mask. By wearing mask, we are closing the ports from where corona can enter, that is nose and mouth. Then the next thing which was told to us is do less contact, don't shake hands, avoid meeting people, avoid physically touching them, and do regular cleaning of your hands. So whatever be the reason, if you are meeting some person, it is better to regularly keep your hands clean, or you are touching some equipment or some object, then go and clean your hands before touching to your mouth. This was told to us. And after all these measures, later on, after a few months and many researchers found that there can be vaccine to avoid and boost our immunity. So these vaccines were incorporated and they were given to us. So a person, once he is vaccinated, we thought, okay, now we have the immunity, now corona is nothing. It's just a myth for us. So we are saved, nothing will happen to us. So we started not following rule number 1, 2 and 3. We said we are vaccinated, we are the kings, we will do whatever we want. But this was a misconception, because you saw that after some time, repeated waves of corona were coming, whether it's second, third, fourth, many corona waves came, many people lost their lives, unfortunately. But even after taking vaccines, it was not 100% surety that you are done and you will never catch virus or you will never have anything. So then later on, again it was told, no, do vaccination but follow the rules also. Don't stop not following the rules. This is what we have understood about corona. Now let us relate to EMC. So this is one equipment. Instead of person, you can assume they are equipments, equipment E1 and equipment E2. Now equipment E1 is radiating. So as this person is radiating through the air, the coronavirus, then equipment also radiates electromagnetic energy. And that is basically the disturbance which we are saying here. And it goes and disturbs equipment E2. So this is through the air where it is traveling. So what we can do is we can reduce this energy value which is coming to us by doing a proper distancing, like social distancing. So that is why you will see EMC engineers keep on telling you that please put your equipments far away as much as possible. Or if you are having a room layout, so power room layout is a different, and make your signaling or communication, let this be a lobby, and then put a signaling room here rather than just putting power room and signaling equipments just together. Try to maintain distance if possible. So this is what is told. So maintain social distancing. Same is for the cables, high voltage cables, and like suppose control cable. So this is our high voltage cable and control cable. They say to prepare proper segregation. It can be 600 mm or 1000 mm depending on the standard which we are following. But we will talk later about the standards and about the cable tray. Suppose you are reducing, you can reduce to 300 mm also by doing some mitigations, by providing perforated cable tray, covering them. All those things will be covered later. I am just giving you a rough example now, that let us suppose the distance maintained is 600 mm between HV and LV, or HV and signaling cable. This was the distance. So this is basically social distancing you are doing between HV and the other affected equipment. So this was social distancing. Now after that, it was told wear mask, protect yourself, protect things. So basically what we are doing is, if we are reducing this segregation to 300, we are saying okay, protect, wear mask. So we are providing a cable tray cover on top in order to act, or in order to help us from getting affected from the HV cable. So anything that could have come and affected us, we are now protected because we have shielded ourselves. Also shield your cables and connect it to earth. So use shielded cables and bond it to earth on both sides. About earthing both sides or bonding both sides of the cable shield, or single side bonding, on in DC traction what we do, AC traction what we do, whether stray current can flow or not. All those things we'll be covering in a different video, but right now we are just giving a basic understanding. So this is why you will hear please provide cover, please do shielding and all those methods. It's basically providing a mask to the human to avoid getting corona. Similarly, mask to an equipment to avoid catching electromagnetic disturbance. Then the third thing is regular cleaning. So regular cleaning is basically as this equipment can be connected together through a cable. So what you have to do, that there can be some virus that can go from here to here, basically disturbance that will travel from one place to another. So what we have to do here, we have to provide something here which can clean it. So this cleaning part is called, basically it is called a filter, and these are also surge arresters. So you will hear always these terms, please provide filter, please provide surge arrestor, in order to mitigate this. So this is the role of filter. It cleans. Basically what if you were doing, you were sanitizing your hands or washing your hands. This is what equipment does by if you provide filter and surge arresters and many other things. The fourth most important thing was, and the most important thing was to get vaccinated, and you need to be vaccinated. So that is what we do to our equipments. We tell equipment, please be vaccinated. That is what EMC engineer tells you, that give a dose of a vaccine which is called, suppose, EN5121-4 or -5. So he tells you, please obey to this standard, please comply to this standard. So basically complying to the standard is taking an injection or taking a vaccine for yourself, same as for the equipment. Now, there can be very different types of vaccines, different types of approaches depending on the electromagnetic zone in which you lie in. It is not necessarily that you have to comply this. There can be other standards which will be provided, which we will discuss later. So this is the role of the whole EMC. Now, as we say, now the subsystem owner will say, as Mr. EMC, I am complied with everything which you told me. Now don't tell me where to put my equipment, where not, because I am EMC compliant. But no, or if some fault comes, he will say, but my equipment was EMC compliant. How can the fault come? So this comes because you are not obeying to the upper three rules. Same, even after taking vaccine or booster dose, even after having booster dose, we would say that now the corona can never occur to us. But we are the kings now, nothing will happen to us. But still corona will happen. COVID virus will attack us from anywhere, anytime. Because we are hesitant in following these rules. So same goes here, that after obeying to the or complying to the required standard, we shall not stop following the rules which are prescribed in the best practices to us, that please keep your equipments away, please keep required segregation and all those things. We'll be discussing all of these in depth. Not only that, now I will just tell you a glimpse of what will be coming in the upcoming lectures. For basic understanding, we'll be talking that source and victim. This is our source and this is our victim. So from here there can be emissions which can be conducted, that is going through this cable. There can be radiated through the air. There can be inductive or capacitive or electrostatic. So inductive capacitive is basically you have a line which is carrying nearby this system, that is source, victim and coupling path. This is your coupling path. So there is a cable that is carrying high amount of current. Basically, let us suppose it's an AC current. So this can induce voltage through Faraday's law in your cable, and this can cause problem. So this is inductive coupling. Capacitive coupling will be, you have this cable is a high voltage cable, so it can cause extra high voltage cables. They can cause capacitive coupling to the nearby. But we'll be going in detail the math behind it and basic models to understand. But now the aim was to understand what is EMC, we have understood. But now the main important part after understanding EMC is working of the standards. How these standards work and on what basis they work. So they work on the basis that this was your source. The first thing that will come in your mind is, let us not emit anything. Why we are emitting? Let us capture everything here itself and not allow anything to move from here to here. Let us not allow this. Let us not allow this radiation to go. So we have to reduce the emission levels. This is the first priority. The second is we have to check the coupling. We have to reduce the coupling. So this is one of these are the coupling. So we have to reduce. We have to avoid capacitive coupling. We have to avoid inductive coupling, conductive coupling radiated. This we shall avoid. How we can avoid, we'll discuss. One of the methods is by shielding, and other method is by creating more distance. That is again going back to the example which we saw, social distancing mask, and we will see that in the upcoming lectures. Then the third is the most important thing is getting vaccinated, taking a vaccine. So by this we are making sure that the victim is highly immune. So first of all, you are not secreting anything, you are not giving out anything, you are not sending or anything disturbances from you. You are trying to control yourself, and the other thing is you are improving the immunity of the other equipment. So this is described here. I will just draw. So basically, let us suppose this is, I'm talking about electric field which are measured in volt per meter, and this x-axis is your frequency. So for a particular frequency, we have certain amount of emissions. Let us suppose these emission value is only 0.01 volt meter. It is just an example. Then your immunity shall be designed very, very high. This is what the standards do. They tell the immunity to be extremely high and emissions to be extremely low. By doing this, what they create, let us suppose this is 20 volt per meter. By doing this, what they create a huge margin between immunity and emissions. And this is called basically a compatibility margin, which is basically your 20 by 0.01, which is nearly 2000. So huge amount of compatibility margin is created so that even if somebody is emitting, let us suppose he tries to emit more, even he tries to come from here to here, still the immunity is so strong that it will not impact our equipment. But for that, you need to follow the standards which are written in the EMC management plan, initially written in the design stage. We'll be going through all these steps in detail. This was just to give you a flavor of what is EMC and what we are doing. Then later on, we will be going in depth for the models, as I told you, for coupling paths. And we will be talking what standards say, what are these enclosure ports, AC power, DC power, what are the values written in it. And later we'll see about the EM zoning. You can pause the video just to see the EM zoning, but this is decided by EN 50.121-4-5 and EN 50.121-3-2. We have used these standards in order to design this EM zoning, which is followed in most of the cases. So I would like to thank you now for listening to this lecture, and please subscribe to my channel, and we'll keep you posted with the next upcoming videos. Thank you.